An electrical circuit that has more than one pathway is called a parallel circuit. In this case, parallel circuit is defined as electrical components with different currents are combined to a single circuit with multiple loops. Here I've given an example with 3 resistors, R1, R2, and R3, connected to one single battery V down here at the bottom. And what you have is you have an overall current coming out of the battery, but then at this junction we have it dividing amongst the resistors. In this case, if R1, R2, and R3 are all equal, then we would imagine that I1, I2, and I3 would all be equally, would all equal one another. However, this doesn't necessarily have to be the case if R1, R2, and R3 do change. But due to Kirchhoff's rules, we do know that the total current at any junction must equal all of the currents coming into the junction and out of the junction. So I equals I1 plus I2 plus I3. And so combining this with Ohm's law and the fact that V equals IR can be rearranged as I equal to the potential divided by the resistance, then this statement can be rewritten as the total voltage divided by what we are now calling the equivalent resistance, or the total resistance of the circuit, is equal to the voltage divided by R1 plus the voltage divided by R2 plus the voltage divided by R3. And so factoring out the V's, we see that V is 1 over Req here, equal to the potential times the sum of the inverses, 1 over R1 plus 1 over R2 plus 1 over R3. And so obviously what we find is that the equivalent resistance for a parallel circuit, something that contains multiple pathways, can be calculated through this calculation. The equivalent resistance is the inverse of the answer of the sum of the inverses of the individual resistors.